So in this video, we're going to look at problems 3 and 4 from the Chapter 3, Part 2 homework. Here we have a plate that's been drilled out 6 times. We're told that every time we drill a hole through it, we exert a torque or a moment of 42 pounds times inches in the clockwise direction. So if you've ever used a drill, this is probably a familiar situation to you. If this thing weren't fastened too well at points A, B, and C, and D, every time you go to drill a hole, it's going to tend to want to torque it in the clockwise direction. So the question is, what force couple system initially could be applied at points A and C in order to induce the same nature of the rotation? So we're trying to have an equivalent force couple system to the effect of drilling 6 different holes. So if we have to apply at points A and C, hopefully everyone sees that if you look at these 2 points, the actual perpendicular distance between them is going to be a vertical line. So naturally, the force couple system is going to be directed along lines of action that are in the horizontal direction. So initially, I draw the 2 lines of action of my force couple pair, and they're going to go through points A and through point C in the horizontal direction. I need to calculate what this force needs to be in order to yield an actual moment equivalent to all 6 of these individual moments induced by the drill itself. So what is going to be the moment of this force couple pair? Well, it's just going to be the unknown force that I need to determine times the perpendicular distance between the 2 lines of action, which we know is actually 12 inches. So that's the first observation we make, is that D perpendicular is 12 inches. We know that whatever F is, when we multiply by 12, we need it to be 6 times 42 times pound inches. And that's just the tendency of each drill hole to induce that rotation. So, and again, I should have added beforehand, if I want to actually induce a clockwise rotation, I have to choose the sense of the forces to go in at F and out at C. If you think about that, that's going to induce clockwise rotation. So what does F need to be? Well, I just need to solve this equation for F. And what I find is that if I isolate F by itself by dividing by D perpendicular, F needs to be 21 pounds in order to induce 42 pound-inches of torque in a force couple pair applied in the horizontal direction at A and C. So the second part of that problem just basically asks you, what would the equivalent force couple system be at A and D? So if you draw an actual line between A and D, which would correspond to the perpendicular distance, you notice that you can actually calculate that by simply using Pythagorean's theorem, where this is the base length of the plate and this is the height of the plate. So you should be able to calculate D perpendicular pretty easy there. And you want to approach the problem the same way that we did for the case when the actual 2 forces were applied on horizontal lines of action.